In this video, we are going to be learning about atoms and elements. Just like the same 26 letters make up millions of different words, there are about 90 elements that make up all the substances in the world. So just like we combine different letters in different ways to make up words, these elements can all be combined in different ways to make up different substances. An important definition is the definition for element. An element is defined as a material made up of one type of atom. So for example, gold has only gold atoms in it, as you can see here. And graphite, which is what your pencil lead actually is. It's not lead, it's graphite. Graphite only has carbon atoms in it. The periodic table is a table in which all elements are listed in a specific order. You may already know what specific order they are listed in, but we will be covering that later. Now we're going to talk about atoms. First, it's important to recognize atoms by their atomic symbol. That is a 1 or 2 letter abbreviation of the element's name. For example, oxygen is abbreviated as capital O. Lithium is abbreviated as capital L, lowercase I. Carbon is abbreviated as capital C. The first letter must be capital, and the second letter must be lowercase. For example, uppercase C, lowercase o is cobalt, but uppercase C, uppercase O is carbon monoxide. Cobalt is metal, but carbon monoxide will kill you. They are extremely different, so be careful with writing your capital and lowercase letters during this unit. In fact, you should always be careful with that. The law of conservation of mass tells us that atoms have been around since the beginning of time. So the atoms that make up your body have actually been around for millions, billions, trillions of years. In the atomic nucleus, protons and neutrons are bonded together at the center of the atom, and the electrons are small, lightweight particles surrounding the nucleus. If you don't know this already, you should know the charges of each of these. So take a minute, see if you can remember that. So, a proton is positive, a neutron is neutral, and then an electron is negative. So atoms are mostly empty space. So this is as much to scale I can get on a PowerPoint, not very to scale as you'll see. So here's the nucleus. Positive protons, neutral neutrons, negative electrons surrounding the nucleus, orbiting it. So, if you were to take a pin and compare it to the scale of an atom, so if the nucleus were the size of the head of a pin, in the middle of a baseball stadium, the electrons would be in the upper deck. So, what we're trying to say here is that between the nucleus and the electrons orbiting the atom, there is a ton of empty space. If atoms are mostly empty space, why can't you put your hand through a wall? Or why can't you put your head through a train like Patrick Swayze does in Ghost? Well, the answer is, first of all, the empty space is very small. Second of all, recall that like charges repel each other. So the electrons in the atoms of your hand will repel the electrons in the atoms of the wall. And in fact, when you are touching the wall, there is an extremely tiny space between your hand and the wall due to an electric charge between the atoms. So it feels like you're touching the wall, but what you're actually feeling is the electrostatic force. So that's kind of crazy. Let's talk briefly more about the atomic nucleus. The nucleus contains positive protons and neutral neutrons. P with a superscript plus sign stands for proton. They are heavy compared to electrons. Protons and electrons, as you should know, are equally and oppositely charged, and as we know, unlike charges will be drawn to each other, they attract each other. So basically the protons in the nucleus will draw the electrons towards the nucleus. And instead of it causing the electrons to move towards the nucleus, it causes the electrons to orbit around the nucleus. Just like the force of gravity from the sun doesn't cause the Earth to go towards the sun, it causes the Earth to orbit the sun. Now, a neutron has the same mass as a proton, and as you should know, no electrical charge. And the symbol is N with a 0, a superscript 0. Now, don't forget your summary for your Cornell notes.